Okay, so let's talk about how do we find if our lines are parallel, perpendicular, or neither when we're given linear equations here. All right, so this deals when it comes to graphing lines, talking about slope-intercept form and all that lovely stuff. And a lot of times you're asked, are the two lines parallel? Are they perpendicular? Or are they neither? Now, you can be given a couple of different examples initially here. For the most part, you are given equations. You may be given two equations, and you're asked the same question. Are they parallel, perpendicular, or neither? All right, sometimes you could be given an example like this here. So we're going to talk about how do we find parallel, perpendicular, or a neither case here if we're given ordered pairs. So here we're given two sets of ordered pairs, -1, 2, and 3, 5, and then 4, 7, and 8, 10. So we're asked, are these two lines parallel, perpendicular, or neither? Now, the way that we figure out if they're parallel, perpendicular, or neither, that pertains to the slope. So the slope of the line is what we need to know. Because if we know the slope of the two lines, and the slope is the same on both of them, if the slope is the same, that's a parallel case. If we know the two slopes of our lines here, and we multiply those two slopes together and we get a -1, that's what a perpendicular looks like. Anything other than that, the slopes are not the same, we get something other than -1 when we multiply, that's what a neither case looks like. So when you're given ordered pairs, you need to figure out, well, how do I find slope when all I have is ordered pairs? We don't have an equation here where we can put it in slope-intercept form and pull out the slope that way. Here we're given ordered pairs, and the way that you find slope when you're given ordered pairs is typically by using the slope formula. This is what the slope formula looks like. Right? Slope is equal to y2 minus y1 over x2 minus x1. So I'm just going to take these ordered pairs over here and I'm going to label them. I'm going to say this is x1, y1, x2, y2, and same thing over here, x1, y1, x2, y2. Doesn't matter which one's number 1 and which one is number 2, just label them here. So what we're going to do is we're going to plug and chug into the slope formula twice. We're going to take this first sets of ordered pairs and we're going to plug away and find the slope of this top one over here. And then we're going to take the bottom points, plug them into the slope formula, and figure out the slope there. Once we know the slope of both of them, then we could go about trying to figure out which case we have. So I'm going to start with the top one over here. So y2, so 5 minus y1, which is a 2, over x2, which is 3, minus x1, which is -1. Simplify this subtraction. 5 minus 2 is a 3, and 3 minus a -1. Double negative rule there gives me 3 plus 1, which is a 4. So slope to line number 1 up here is a 3/4. I'm going to do the exact same thing here, but I'm going to do it with the bottom ordered pairs here. So y2 is a 10 minus y1, which is 7. x2, 8 minus x1, which is 4. And subtract. 10 minus 7 is a 3, and 8 minus 4 is a 4. So slope for the second line is 3/4. So first, are they parallel? Parallel has the same slope. So 3/4, 3/4, that's exactly the same thing, right? I mean, 3/4 is exactly the same thing as a 3/4. So the slopes do equal each other. So these two lines are parallel to each other.